Assalamu alaikum wa rahmatullah. Ladies and gentlemen, I am pleased to participate with you in the conference entitled Emerging Research Trends in Geography. My working paper is titled Spatial Simulation of Future Urban Expansion Using Artificial Intelligence in GIS, a case study of Erbil Plain District. My name is Umar Abdullah Ismail Qasab. I work at the University of Mosul as an assistant professor. I will start my worksheet with the three main questions as follows. 1. What are the current and future needs of the population for urban land area in the Erbil Plain District? 2. How suitable is the current land to accommodate urban use in the Erbil Plain District, considering the sustainability of adjacent agricultural land? 3. What are the future scenarios of urban spatial expansion for the Erbil Plain District in terms of the sustainability of adjacent agricultural land? This is the geographical location of a study area. The Erbil Plain District has flat land in general, and it is located south of the Erbil Governorate, and the Governorate is in turn located in north of Iraq. This worksheet will include three main parts or stages. The first stage includes land cover classification for the satellite images of the Landsat series for three time periods, 2002, 2012, and 2019. This is in order to capture the urban area from the three periods. This stage also includes the estimate of the current and future population needs for urban land until 2029, based on the standard of the Iraqi Ministry of Planning, which specified 100 meters of urban land for each person. It is observed that there is a surplus of the urban land in all district center of the Erbil Plain District, except for the Banslawa sub-district. By 2029, Banslawa is expected to face a shortage of urban land estimated at 89.69 hectares. This shortage is due to its role as the center of the Erbil Plain District, where the population density is high, creating a greater demand for urban land to meet future needs. In the second phase, spatial modeling was conducted to evaluate land suitability for urban spatial expansion. This process involved incorporating a set of factors, including repulsive factors that hinder spatial expansion and attractive factors that promote it. The repulsive factors for urban spatial expansion include the land's capability for agricultural production, modeled according to the standards of USDA. Another factor was the land's suitability for cultivating strategic crops, a model developed based on the FAO. This is based on the premise that agricultural lands are a national treasure that cannot be replaced if lost. The second type of variables that were adopted in the land suitability model for urban spatial expansion are the attraction factors, which are slope, groundwater as the only water resource in the district, a proximity to main transportation routes, and finally, a proximity to the current urban area. A few factors when they choose because the land of the Erbil Plain District is generally flat, except for the eastern side. To complete the process of building a suitability model for urban spatial expansion, the factor measures were standardized using mathematical functions available in our GIS desktop software. The unified scale ranges from 1 to 10, where the value 1 represents the least attractive area for expansion, while the value 10 represents the most attractive area for expansion. This standardization was achieved using small and large mathematical functions. The final step in building a suitability model for urban spatial expansion involved using the HP technique to determine the weight of the factors included in the model. The proximity to urban land factor received the highest weight, while the groundwater productivity factor received the lowest weight. As for the remaining factors, their weights ranged from high to low. Now, two scenes have been obtained from the suitability of the land for urban spatial expansion. The left scene represents urban spatial expansion taking into account the sustainability of all agricultural groups, while the right scene represents urban spatial expansion considering the sustainability for cultivating only strategic crops, as wheat, barley, and corn. These two scenes or models will serve as the basis for building urban expansion scenarios, as will be explained in the subsequent slides. Based on previous procedures, the three scenarios for urban spatial expansion were developed. Scenario 1, comprehensive sustainability. This is a standard scenario representing urban spatial expansion in the centers of subdistricts within the Erbil Plain district, driven by urbanization due to a growing urban population. The expansion is planned while ensuring the sustainability of agricultural land for all crops, including grains and vegetables. Scenario 2, strategic crop focus. This is another standard scenario representing urban spatial expansion in the centers of subdistricts within the Erbil Plain district, also driven by urbanization due to growing urban population. However, this scenario specifically considers the sustainability of agricultural land, is suitable only for the cultivation of strategic crops. Scenario 3, urban priority. This is a projective scenario representing urban spatial expansion in the centers of subdistricts within the Erbil Plain district, driven by urbanization due to growing urban population. Unlike the first two scenarios, this expansion doesn't account for the sustainability of agricultural land. Each scenario reflects different planning priorities and approaches to balancing urban growth with agricultural sustainability. A simulation model for urban spatial expansion was employed consisting of a composite approach that integrates artificial neural networks, serial automata, and fuzzy logic. This model is programmed within a specialized extension, GIS, Geographic Simulation and Optimization Systems, which operates in ArcGIS desktop environment. Before using the GIS extension, the conditional boundaries for specific scenarios were built. Scenario 1 was based on fuzzying the agricultural land capability, while Scenario 2 focused on fuzzying the land suitability factor for strategic crop cultivation. Finally, Scenario 3 was created by defining a raster surface with a value of 1 using fuzzy logic. The results of spatial effects of urban spatial expansion provided highly confident statistical indicators, both at the level of training artificial neural network and data validation, as well as the accuracy of the overall simulation result, including the kappa coefficient. Therefore, these results can be confidently relied upon to explain the impact and dimension of urban spatial expansion through 2029. Now we can see how urban area expansion happens in the future according to the scenarios. In Scenario 1, urban expansion moves more toward the north and east, especially in the Kaznazan district, where the land is least fertile. Also, in the Qoshtapa district, the urban area is similar in Scenario 1 compared to Scenario 2 and 3. This is because Qoshtapa has fertile agricultural land, so expansion is more controlled in Scenario 1. In this slide, the loss of agricultural land can be observed according to its categories from the perspective of land capability and its suitability for cultivating strategic crops. Scenario 1 shows the least loss of high-quality agricultural land, especially within the top 3 categories of suitability and capability. However, from the list 2 categories, Scenario 1 shows a higher loss of land due to its lower fertility compared to the other 2 scenarios. Similarly, Scenario 2 shows the least loss of high-quality agricultural land and higher loss of low-quality agricultural land compared to Scenario 3 overall. The research reached several conclusions, the most significant of which are summarized as follows. 1. Urban expansion in the Erbil Plain district has been steadily increasing, taking over agricultural land. Between 2002 and 2019, the urban area grows significantly. By 2029, it's expected to expand by another 27 square kilometers, based on the average growth rate from different scenarios. Without a proper planning, the district will gradually lose its agricultural character and become more urbanized. 2. The spatial scenarios created using the ANNCA simulation model show the urban areas in the Erbil Plain district are expected to expand by about 27 square kilometers by 2029. If the expansion continues at the same place, the highly suitable lands for urban growth will be enough to support urban development for the next 60 years, while keeping the land sustainable for all types of crops. However, if the focus is only on sustaining lands for growing strategic crops, this period could extend to 90 years. Thank you for your attention.